Every motor you're about to see passed the dealer inspection. Every one of them started on the first turn of the key and ran perfectly on the test drive. And every one of them was hiding something the owner wouldn't discover for years, until the bill arrived. One of these engines quietly rots from the inside, in a place no flush can ever reach. One carries a computer that literally counts down the hours to its own failure. And one didn't just cost owners money. It caught fire, it exploded, and it dragged a 93-year-old American giant into bankruptcy 3 days before Christmas. These aren't rumors. Behind every motor in this video, there's a paper trail, service bulletins, recall letters, and quiet fixes the companies never advertised. We rank them from the cheapest surprise to the one that killed a company. Because 4 of these engines are still out there, sitting on transoms and used boat listings right now. And by the end, you'll know exactly how to spot every single one before it's bolted to your boat. Before we start, one thing. Every defect in this video turns into a 5-figure bill for one reason. The owner walks into the shop not knowing what the repair should actually cost. That's why I put together the Outboard Repair Defense Guide. Every common repair, its real price, the warning signs to catch a problem while it's still cheap, and the tricks some shops use to pad the quote. If you own an outboard, grab it now. The link is the first one in the description. It costs less than half an hour of shop labor, and catching one inflated estimate pays for it many times over. The people who go looking for it after the shop calls are already too late. Okay, ask around any marina about Honda outboards and you'll hear the same word every time: bulletproof. That reputation didn't start on the water. It was imported straight from the driveways of America, built by millions of Civics and Accords that refused to die. When Honda launched the BF225 in the early 2000s, the pitch practically wrote itself. This was automotive engineering hung on a transom, a 3.5-liter V6 pulled from the same family of engines that powered the Odyssey minivan. Buyers who wanted to sleep at night bought the Honda. That was the whole sales argument. Which is exactly why what happened next stung the way it did. The original exhaust design on the BF200 and BF225 had a flaw that nobody could see and the brochure never hinted at. The exhaust tubes allowed water to surge too far up into the engine, much farther than the design intended. In the milder cases, that water reached the oxygen sensor and killed it. And some owners found themselves replacing that sensor year after year without ever learning why. In the worst cases, the water kept climbing until it reached the cylinders themselves. An engine that swallows water doesn't wear out. It hydrolocks. And the hydrolocked engine can destroy itself in a single moment because liquid doesn't compress and pistons don't negotiate. Honda knew. The proof is a document called Service Bulletin Number 56, issued in 2006. And it reads with the precision of a confession written by lawyers. It names the exact serial number ranges. BF225s below BAGJ1500324 and BAHJ1500022, along with the matching BF200 ranges. And it prescribes redesigned exhaust tubes to fix the problem. It even specifies a clearance requirement. The exhaust outlets need to sit at least 5.9 inches above the waterline. In warranty, the repair was covered. Out of warranty, owners could petition for what Honda called goodwill consideration. You had to ask, and you had to receive a decision before any wrench turned. Think about what that means for the used market. 20 years later, those affected serial ranges are still out there, and whether any individual motor got the upgraded tubes depends entirely on whether some previous owner saw the bulletin and acted on it. The engine itself won't tell you. It runs perfectly, right up until it doesn't. And the exhaust tubes were only the first layer. These motors also developed a deeper problem: corrosion inside the block itself, in the water passages around the cylinders and heads. One documented case tells the whole story. An owner bought his BF225 in 2009 and flushed it after every single use. 6 years in, corrosion claimed his lower unit. 2 years after that, water started shooting out from under the cowling. The block and heads had rotted through from the inside. The repair estimate came to $8,000. Honda's answer this time was that they couldn't help. 8 years of religious maintenance, and the motor died anyway. Now, for the honesty this channel owes you, a Coast Guard mechanic who serviced these engines daily reported seeing BF225s past 4,000 hours with nothing but routine maintenance. And he'd never personally seen one with a hole in it. Motors that run constantly, that never sit and dry out, seem to live long lives. The ones that fail tend to be the weekend boats. So this isn't a death sentence on a serial number. It's a coin you don't have to flip because the serial ranges are public. And checking whether the tubes were ever replaced costs one phone call to Honda with the number off the mount. The third motor on this list needs no introduction on this channel, but this time we're telling a different part of the story. The first generation Yamaha F225 has already had a full investigation on this channel, so we won't retrace every detail here. If you own one of those V6 4-strokes from 2000 to 2005, or you're thinking about buying one, that video walks you through the 2-minute check that settles the question. The link is in the description. What belongs in this video is the part of the story we didn't tell. Because the F225 didn't just have a defect, it exposed how the industry handles one. Quick context for anyone new. Those early F200, F225, and F250 motors corrode from the inside, in the dry exhaust passage, a section that carries hot gas down through the midsection and never sees a drop of cooling water. Left alone, the rot eats through toward the oil pan, and a $3,000 repair becomes a dead powerhead. The corrosion hides where no inspection reaches without dropping the lower unit, and the motor runs flawlessly while it happens. Here's what that concealment produced. When the first ruined engines started arriving at dealerships, the explanation many owners heard was that they had done this to themselves. Poor flushing, neglect, salt water left sitting in the motor. It took marine surveyors cutting open dead engines to dismantle that story, because the corrosion sat in a passage that flushing cannot touch. Water never flows there. No maintenance routine on Earth could have prevented it, which means the most careful owners on the dock were being told to blame their own habits for a flaw that shipped from the factory. Then came the quiet part. Around 2006, Yamaha changed the internal coating on the exhaust components, a non-stick treatment on the later 3-star emissions engines, and the problem largely disappeared from that point forward. If Yamaha ever announced the change, the people running the earlier motors never heard about it. The fix arrived the way fixes usually arrive in this industry. Silently, inside the next generation, discoverable only by the people who compare part numbers. A company rarely announces the solution to a problem it never admitted having. And the 2006 coating change is the closest thing to an admission the first generation owners ever received. That pattern is worth holding on to because it repeats. A defect surfaces, owners get blamed. The next generation quietly contains the cure. You saw a version of it with Mercury's redesigned compressor. You saw it with Honda's revised exhaust tubes, buried in a service bulletin most owners never read. The F225 matters on this list because it's the case where the pattern was proven, where independent surveyors put the manufacturer's explanation on a table next to the physical evidence and the explanation fell apart. It also taught buyers a skill, and that skill is the real inheritance. Before the F225, a clean cowling and a smooth test run counted as due diligence on a used outboard. After it, surveyors started telling clients something different. The outside of a motor tells you nothing, and the only opinion that matters comes from a boroscope. One buyer spent $400 scoping a pair of these engines before purchase, found corrosion in both, and pushed the repair cost back onto the seller before a dollar changed hands. He called it the best money he ever spent. That habit, distrusting the surface, demanding to see inside, is exactly what the last two motors on this list require. Because both of them looked magnificent right up to the moment they came apart. And the next one didn't come apart quietly. It came apart at 300 hours, at ordinary cruising speed, bolted to the biggest boats Yamaha had ever produced. In 2007, Yamaha did something no outboard maker had ever done. They built a V8 from scratch for the water. Not a converted car engine, but a 5.3-liter powerhead designed for the transom from the first bolt, with more than 600 new parts. The F350 existed for one reason. Boats were getting enormous, and nothing on the market could push them. It worked so well that it arguably created the modern era of giant outboard boats. Builders started drawing hulls they never would have dared before, because now the power existed to move them. Grady White hung 4 of them on the transom of a single boat. The F350 wasn't just Yamaha's flagship, it was the permission slip for an entire category of boat. Then the flywheels started coming apart. Techs servicing these motors around the 250-hour mark began noticing something on the flywheel damper. The rubber ring that doubles as a harmonic balancer was shedding. That was stage 1. Stage 2 showed up as diagonal cracks spreading between the hub and the outer ring. Stage 3 was separation, and separation on a spinning V8 is violent. The imbalance hammered the top crankshaft bearing and took the stator with it. One owner with twin F350s on his 33-footer got the full sequence at around 300 hours. His flywheel vibrated itself apart and the shaking cracked the crankshaft. Yamaha put an entire new long block in that motor. Then customer service called him to say they were replacing the flywheels on both engines. His incident, and others like it, had forced their hand. The cause traced back to something almost invisible. At a specific band of engine speed, right in the range where boats spend hours crossing to the finishing grounds, the crankshaft generated a vibration too subtle for anyone at the helm to feel. The flywheel felt it. Heat built in the damper, the rubber degraded, and the countdown began. Below that band, nothing. Above it, nothing. The defect only lived at cruise. Yamaha's response is the most unusual fix on this list. Letters went out to owners announcing a service upgrade. Their word, chosen carefully, because the number of failures was called isolated and the word recall never appeared. Dealers installed a new flywheel, a vented cover to shed heat, and eventually something stranger. A new engine computer whose job was to log every hour the motor spent inside the dangerous RPM band. At 80 logged hours, a warning light comes on and the flywheel gets replaced. Free for the life of the engine, as many times as it takes. Sit with that for a second. Yamaha's solution to the F350 was a computer that counts down to the failure of its own part. No other production outboard has ever shipped with its weakness scheduled into the software. To their credit, it worked. After the preventative replacement program matured around 2015, the reports of catastrophic failures essentially stopped. Some owners had flywheels swapped twice and shrugged it off as a free service visit. The engines themselves, between flywheels, earned genuine loyalty, smooth and quiet and strong. But the flagship never escaped its reputation. Some builders stopped offering it factory-rigged. In the summer of 2019, the last V8 F350 left the line with no farewell and no successor, leaving a hole in Yamaha's lineup between 300 and 425 horsepower that sat open for 5 years. When the F350 name finally returned in 2024, it was bolted to a completely different engine, a V6. The name survived, the V8 didn't. Every motor so far cost owners money. The last one cost 7,000 people their jobs. To understand what died in December of 2000, you have to understand what OMC was. Outboard Marine Corporation owned Evinrude and Johnson, the brands that invented the outboard motor in 1907 and at their peak controlled half the world market. Even in decline, a third of the outboards sold in America carried their name. This was a Fortune 500 company with 13 boat builders under its roof, factories in 12 American cities, and nearly a century of trust behind it. Companies like that don't vanish. And then one did, in about 4 years, because of a single engine. The pressure came from the same place it came from for Mercury, the EPA. Facing the new emissions rules, OMC made the same bet. Saved the two-stroke with direct injection, and licensed a German technology called Ficht to do it. The technology itself was genuinely good. The engineers who worked with it said so, and what Bombardier later built from it proved them right. But Ficht demanded manufacturing precision that OMC by the late 90s no longer had. The company had shut down its own parts plants and scattered production across outside suppliers and a new factory in Mexico. And the parts coming back seldom met specification. Precision technology was being assembled from imprecise pieces. Prototype failure rates were high, and OMC shipped anyway. What followed was carnage. Power heads seized. Owners described pistons and rods erupting through engine blocks. Warranty claims poured in, and each one devoured the thin profit margin the motor carried. OMC ended up replacing some power heads 3 or more times on the same engine, which means they would have lost less money never selling it at all. Then it got darker. Between July 1999 and December 2000, the company was receiving reports of fires and explosions on its 200 and 225 horsepower Ficht motors. A fuel leak defect the Coast Guard would later declare a substantial risk of injury to the public. On December 22, 2000, 3 days before Christmas, OMC filed for bankruptcy, carrying roughly $800 million in debt. 7,000 people lost their jobs. The head of engineering remembered the day before the filing when the investors called everyone in and said it was over. Ficht didn't act alone. A softening boat market, the outsourcing chaos, and heavy debt all pushed, but here's the detail that settles the argument. When the company filed, 7 of its 8 boat builders were profitable. The boats were fine. It was the engines, the thing OMC had done better than anyone alive for 90 years, that pulled everything under. The strangest chapter came after death. Bombardier bought the Evinrude name in February 2001 and immediately recalled the dangerous Ficht motors, absorbing the full cost of fixing engines built by a company that no longer existed. Then their engineers rebuilt the technology properly, and in 2004, ETAC won the EPA's Clean Air Excellence Award. The idea was never the defect. 20 years of borrowed time later, in May 2020, Evinrude production ended for good. The brand Ficht wounded never recovered. And that's the uncomfortable truth OMC left behind. The engineers always get there. Every troubled motor in this video eventually became a good one. Some became great ones. What kills engines, and occasionally companies, is the calendar. The launch window closes, the quarter ends, and a design that needed 1 more year of testing ships to a dealership instead. The people who fund that missing year are never the ones who made the decision. They're the ones standing at the transom holding the receipt. So bring the patience the manufacturer skipped. Never buy the first year of anything. Never trust a clean cowling. And always ask what changed in Generation 2. Because the changelog is where companies tell the truth.